Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you about calculating OR and probabilities. In this presentation, we learn how to calculate OR probabilities. For example, when considering the experiment of rolling a six-sided dice, you'll be able to calculate the probability of rolling an even number or rolling a prime number. You also learn how to calculate AND probabilities. For example, when considering the experiment of rolling two six-sided dice, you'll be able to calculate the probability of rolling an even number on the first roll and rolling a prime number on the second roll. To calculate OR probabilities, that is the probability that event A or event B occurs, is given by the following formula. Probability of event A or B is equal to the probability of event A plus the probability of event B minus the probability of A and B. That is the probability that both A and B occur. It is possible to calculate OR probabilities without using this formula. Many times you can use the definition of probability and count the possible ways that the events can occur. In the formula, the subtraction of probability of A and B is removing double counts. There are scenarios where the number of ways that A can occur and the number of ways that B can occur actually have some overlap. Let's consider the example of having 12 pieces of paper numbered 1 through 12 and putting those pieces of paper into a hat. A single number will be drawn at random from the hat, and we wish to find the probability of selecting a number less than 8 or an even number. The probability of selecting a number less than 8 or an even number using our OR probability formula would be the probability of selecting a number less than 8 plus the probability of selecting an even number minus the probability of selecting a number less than 8 and even. If we take a look at how to calculate the probability of selecting a number less than 8, we'd find that that is 7 out of 12, because of the 12 numbers, there are 7 numbers less than 8. To calculate the probability of selecting an even number, we can count the number of even numbers, and we find that there are 6 even numbers out of the 12 numbers. So the probability of selecting an even is 6 out of 12. To calculate the probability of selecting a number less than 8 and even, we'll think about numbers less than 8 that are also even. Those are the numbers 2, 4, and 6. So that's 3 numbers out of the 12. So putting that all together, we end up with 5/6 as our probability. That's computed with the 7/12 plus 6/12 minus 3/12. Calculate AND probability. Use the following formula. Probability of A and B is equal to the probability of A multiplied by the probability of B. The big note on this formula, and that is that the probability of B must be calculated assuming that A has occurred. There are times when the occurrence of A will affect the probability of B. There are other times when the occurrence of A will have no effect on the probability of B. But calculation must take place when using this formula. That is, the probability of B must be calculated, assuming that A has occurred. consider the following. Consider the experiment of drawing two cards. Find the probability of the following. Excuse me. Probability of an ace on the first card and a king on the second card if the cards are drawn without replacement. That language, drawn without replacement, means that you select your first card and you keep it, and then you select another card. Probability of ace on the first card and a king on the second card. That's assuming that the cards are drawn with replacement. And again, this replacement would be you select a card and then you put it back in the deck before you select the second. C, probability of ace and king if the cards are drawn without replacement. So we'll assume that they're drawn without replacement. And lastly, D, the probability that we select two aces if the cards are drawn without replacement. Take a second and try these probability problems using our properties of probability and our new formulas for OR and AND probabilities. Pause this presentation, and when you're ready to check your answers, resume play.